Okay, so this section, Q4, is going to be connecting intercepts and zeros. Okay, so what we're going to do is we're going to start with kind of remembering how to graph a function from standard form. So I'm going to do this question. I'm going to pull this off to the side and kind of do it on my own, if that's all right with you. So we're going to do y is equal to x squared minus 4x minus 5. Okay, so if I was going to graph this from vertex form, I'm going to first figure out what the vertex is. So to do that, I have to come up with the h value, which by definition is negative b over 2a. Okay, so remember that this is in the form of ax squared plus bx plus c. So the a is the number that's in front of the x squared, which in this case happens to be invisible, although it does exist, which happens to be 1. The b value is in front of the x, so this one is negative 4. This c value is negative 5. So negative b, so negative 4 makes a positive 4. And then 2 times 1 on the bottom, so 4 over 2 makes 2. Okay, then we can find the k value, and all you do is you simply plug the h value into the x of our function. So 2 squared minus 4 times 2 minus 5. So that's going to give us 4 minus 8 minus 5. And 4 minus 8 is negative 4, and negative 4 minus 5 is negative 9. Okay, so that's going to give us a vertex of 2, negative 9. Okay, so I can go and draw this. So I can plot the point 2, negative 9, right there. Okay, and another easy point for me to find would be the y-intercept. So let me show you how you find the y-intercept. Okay, so if you think about any value that exists on the y-axis, this one right here, okay, what do you know about the x value of any point on this? Okay, the x value will always be 0. So if I take 0 and I plug it into my equation, my x, that will tell me what my y-intercept is. Okay, and when it's in standard form, it's very easy. I can just kind of go 0 minus 5, so that gives me a y-intercept of negative 5. Okay, so I can plot that 1, 2, 3, 4, 5. I can reflect that across the axis of symmetry, and there I have a parabola with 3 exact points. Okay, so now the second part of this is using zeros to solve quadratic equations. Okay, so we are going to take this piece and we're going to solve an equation by graphing it. Okay, so I'm just going to slide this over here. So we got 2x squared minus 5. 2x squared minus 5 is equal to negative 3. Okay, so we can solve this by graphing. So what we're going to do is we're going to start by setting the equation equal to 0. Okay, so to do that, I'm going to add 3 to both sides. So I have 2x squared minus 2 is equal to 0. So essentially, the equation that I'm going to be solving for, or graphing, is y equals 2x squared minus 2. Okay, so that is technically in standard form. I can find my vertex. So my vertex, again, is negative b over 2a. Okay, so what's the b of this particular equation when there is no x? Okay, so what would make the x go away? A value of 0. So if we have 0 over really anything, in this case happens to be 4, we still get an h value of 0. And then to get my k value, I'm going to plug that back in. And 0 squared is 0, 0 times 2 is 0, and 0 minus 2 gives me a k value of negative 2. So my vertex is 0, negative 2. Okay, so I'm going to take that and I'm going to graph that very carefully down to, okay, and then the slope of my function is 2, so I go up 2 over 1. in both ways, and then I'm going to graph this parabola. Okay, so how do I use this graph to solve? Okay, so think about what we did in this step here. Okay, we set our equation equal to 0, and then we said, okay, we're going to graph y equals that same thing. So essentially what we're saying is that the y value is equal to 0. Okay, so if you think about our graph, where on our graph is the y value equal to 0? Okay, the y value will always be equal to 0 at the x-axis. Okay, so what we're looking for now is our x-intercepts. Okay, which is another fancy word is going to be called the zeros. Okay, so the zeros or the x-intercepts are the same thing. Okay, the idea is that we take our equation, we set it equal to 0. Okay, and that is where the solution to our equations lie. So what are the two places where this function crosses the x-axis? Okay, we're looking at 1, x equals 1, and x equals -1. Okay, and we can test these two answers if we plug them back into our original equation, and they would both be true. Okay, so I'm going to do that one more time, just so you can see exactly what I'm doing. Okay, so I'm going to do this one right here. Okay, so again, I'm going to take my equation, I'm going to set it equal to 0. So I'm going to start by adding 3. So we got x squared, -4 plus 3 is -1. So the equation that I'm going to graph is x squared minus 1. Okay, I'm just going to do a translation on this one. If we have a -1 at the end of my function, what direction does that move? Okay, it's going to take my function down 1 unit. Okay, so my vertex is at 0, -1. Okay, my slope is the value that's in front of my x squared. It's invisible this time. Invisible value is the value of 1. So I'm going to go up 1, over 1 in both directions and plot points. And there's my parabola. Okay, so all I'm simply looking for is where this function is crossing the x-axis. And I can say that it absolutely crosses at 1 and at -1. And those are the two solutions to my equation. Okay, so that's all we did in this section. That should be enough for you to finish the Q4 worksheet.